All right, so we're given this limit problem. We're being asked to find the limit as x approaches 2 of 1 over x minus 2. So we don't have a plus or a minus in our exponent, so we're really being asked to find the overall limit of this equation. What I always tell people is always try option 1. Option 1 to me is just plug that x value in. So plugging 2 in everywhere we see an x in this equation. So what that would look like, it doesn't work all the time, but it works often enough that it's always worth trying. So we get 1 over, and then plugging in 2 for x, we get 1 divided by 2 minus 2 would give us 1 over 0. So option 1 fails. We get division by 0, right? The biggest no-no in all of math. And so at this point, we'd say, okay, what are my other options? And you'd kind of start going through the list of your standard options. We can't factor and cancel here. There's no way to do that. There's no fractions, complex fractions or absolute values. So really all of your standard methods are going to fail on something like this. And when you run into something like that, what you're probably looking at is most likely a vertical asymptote. And when all other options fail, that's when you really want to try what I just call this big small game. So it's more of a conceptual game. That's kind of the hardest part about vertical asymptotes is finding vertical asymptotes is way more conceptual than it is, doing some algebra and arriving at a final conclusion like earlier methods. So when we hit this problem up, the first thing we got to say is, okay, I am dealing with an overall limit, right? So because I have an overall limit, this really still breaks back down into, does my left-hand limit equal my right-hand limit? So whenever you're trying to find an overall limit, this is always how this process works, right? It seems strange, but it's the same things that you've been doing. Does the left-hand limit equal the right-hand limit? So we really have, does the limit as x approaches 2 from the left of 1 over x minus 2, what is that going to equal? And then we have a right-hand limit we have to work with. So limit as x approaches 2 from the right of 1 over x minus 2. What we're going to do right now is we're basically going to do a modified version of option 1. We're going to still try plugging in a value, but we're going to do it sort of by choosing a number based upon what we're looking for here. So on this one, I'm looking to approach 2 from the left. So if you think about that in terms of a number line, if I have 2 right here, coming at that from the left, something really close to 2 from the left would be something like 1.999999999, right? The more nines I put, the closer I get to 2. And so what I'm going to do on a problem like this is I'm going to essentially plug that value in and use that to help me sort of mentally work through what I'm seeing. So I'm going to have 1 divided by, and now instead of x, I'm going to plug in something close to 2 from the left. So 1.999999999 minus 2. We then kind of start cleaning this up. And what you're going to see here is on top we have a 1. And on the bottom we have 1.999999 minus 2. And so 1.99999, no matter how many nines I put on there, it's always going to be smaller than 2. So we know that that value is going to be negative. And essentially what we'd be looking at is negative 0.000000, right? How many ever zeros would be based upon how close we get. So we're just going to have a ton of zeros and a 1 always. How that works out sort of as a mental game is you would say to yourself, okay, on top here I have a 1. A 1 is a big number in comparison to these super small decimals we're talking about. And it's positive. So we would have a positive big number on top. And that's going to be divided by this extremely small number. The more nines we put on that 1.999, the smaller that decimal was going to get. And so what we have on the bottom is we have a negative small value. You can see if you sort of put a problem like this into your calculator is going to give you a huge number out. So what we're really looking at is something huge right now. Something huge in math, right? It would just keep getting bigger and bigger. We call that infinity. The last move we always have to do is we have to check what was the sign of that infinity. Is this headed to positive infinity or negative infinity? And so if you look up in the front here, you have a plus over a minus. A positive and a negative is always going to result in a negative. So right now we know that our left-hand limit, the limit as x approach 2 from the left, is going to equal negative infinity. Getting that much out right there is enough to tell us that we definitely have a vertical asymptote at that location. Just having one of your limits, the left or the right, equal plus or minus infinity, that tells you for sure that you've got a vertical asymptote happening. And now we're going to kind of basically go right now and see, like, does the right-hand limit line up with that, or does it not line up with that, right? Does the right-hand limit equal the left-hand limit? So now we're going to play the same type of game, this little mental game here. This is 1 over x minus 2. We're coming at it from the right this time. So going back to our number line, if we come at 2 from the right, that's going to be a number like 2.00000, right? As many zeros as we want. The more zeros, the closer we get. So we're looking at 1 over 2.0000, right? 1 minus 2. So as we unlock that package there, what we're going to see is on the top we have that 1 still. And on the bottom now, we've got 2.0001 minus 2. So no matter how many zeros we put on that 001, it's still going to be just slightly bigger than 2. So we have on the bottom is really a positive, extremely small number, right? 0.00001. We play our same little game here to kind of figure out about the final conclusion. So on the top, I have a positive big number. 1 is a big number, and it's positive. And on the bottom now, I'm going to have a positive this time, extremely small number. So then what we can see is what we saw before, which is that this thing is 1 divided by a very small number is going to be huge, right? So then we come in and we do the idea. So huge in math speak really means infinity. This time, though, we are headed to positive infinity. A positive over a positive would end up giving us a positive infinity. And so we got 2 different answers out, negative infinity and positive infinity. Right-hand limit is positive infinity. So we definitely have a vertical asymptote there. However, when we come to draw our final conclusion about what that overall limit is going to be, what is the overall limit as x approaches 2 of 1 over x minus 2? Well, what we found out is that our left-hand limit did not equal our right-hand limit. Those went to 2 different places. And so that tells us then that our overall limit does not exist, DNE. If they were both headed to positive infinity, then you would have put positive infinity at the end of this. If they were both headed to negative infinity, we would have put negative infinity at the end of this. But the other conclusion to remember here is that it doesn't matter if that overall limit existed. That doesn't determine if we have a vertical asymptote or not. It was literally that one of these equaled infinity. Both of them happen to work out here. But that tells us when we see that we know we have a vertical asymptote at the x value we were approaching. So we have a vertical asymptote at, as x approaches 2, so at x equals 2.